the people I know who are the best at what they do are the ones who don't kind of try to avoid all errors. They're the ones who are aggressive and try things and then understand that they will make mistakes, that they will sometimes screw up, but then use that as a source of learning to get better. So I just see a real big parallel between people and the AI approach to software for that errors are the greatest source of learning.
Welcome to the Unlearn podcast, where host Barry O'Reilly seeks to synthesize the superpowers of extraordinary individuals to think big, start small, and learn fast. Here's your host, Barry O'Reilly.
Welcome to the Unlearn podcast. On this show, I'm delighted to be joined by Bill Higgins, Director of Watson Research and Development at IBM. Now, Bill leads the integrated research and development team who evolves the foundational IBM AI technologies, powering IBM and their main products and systems. He's interested in culture, in tech, especially as it relates to increasing diverse representation and technical leadership. Now, I've got to know Bill over the years. We first met at O'Reilly Media's camp called Foo Camp, where they invite different authors or people from all over the world to spend 2 days camping in an orchard outside their offices. It was great. I was inspired by his insight, his intellect, and over the years we've got to work together and follow one another in our work, whether on learning, applying AI technologies. And what we're going to share is some of the conversations we've had as Bill has had to unlearn as he gone through various stages of his 20-plus year career in IBM as one of its distinguished engineers and leaders. So before we jump to what he's doing today, let's understand a little bit about what inspires him and took him on the path.
I always work on software products, but at a certain point, I say, I'm really unhappy with the methods and tools we're using to build these software products that we could do so much better. So in the early 2010s, I really became enamored with the DevOps movement, and I really started studying companies like Etsy and Netflix, started talking to people like John Willis, and just trying to really understand the what, how, and why of DevOps, and started to try to drive a DevOps culture at IBM, and was pretty good, pretty successful. And then because of that, we were one of the first teams that got sent to the IBM design camp for product teams. So there was this massive design transformation that Phil Gilbert led back then. And what they would do is they would send kind of strategic product teams to the design camp for a week for basically indoctrination, because it was such a different kind of way of working than we were used to. And I'll never forget, I have a good friend named Adam Cutler, who's a distinguished designer at IBM, and he's got this kind of canned motivational speech about why design thinking. And it really moved me because the gist of it was you really have to understand the markets and the user's needs better than they do so that you could create breakthrough solutions that really solve those needs. And it feels silly saying it now, but back then, that concept of really trying to deeply understand user and market needs was kind of a novel concept to me.
Absolutely.
And I just asked myself, how did I not learn this earlier? Because I'd had so many situations where I felt like I knew my team like wrote really good code, and then the thing would just thud in the marketplace. And so I literally cold called Phil Gilbert that day and said, I would like to work with you. Like, I'm the DevOps guy. I would like to work with you to kind of bridge DevOps and design thinking, because people see them as at odds. And the engineers certainly see the designers as kind of taking away their agency, because engineers are used to just building what they want. And so I actually joined the design group for 2 years. I was like the lone engineer in the design group, and actually got off kind of the technical fast track at IBM, and people thought that was nuts. But I just really wanted to deeply understand this design thinking and figure out how to synthesize it with DevOps. And one of the things we realized was that one of the basic problems was that the designers and the engineers lived in different virtual places. Like, I'll never forget one time we were interviewing a product management lead, engineering lead, design lead of the same product. And the engineer was describing their backlog process. They say, every sprint we go through the stories, we rank them, we order them, we size them, and we figure out what's going to be in the sprint. And honest to God, the product management lead and the design lead says, that sounds really useful. Can we have access to that? And it's like, wait, you guys aren't working together on the backlog? And that, plus sort of another confluence of events, caused me to propose that we build a centralized tool chain that was really inspired by Etsy's tool chain. I had gone up to Etsy a few times and visited Rafe Coburn and John Allspaw, and they showed me how Etsy worked. And I was like, oh my God, this is the future. Like, if IBM could do anything like this, we would just be so much better. And
Yeah.
so that led to that project that you know about, the Whitewater project, where we rolled out GitHub Enterprise, Slack, Travis CI. What we basically did was we picked the tools that we thought the people would most want to use, even though at the time they were frankly not nearly ready for our size and complexity. But the bet was, I bet these great companies and these great teams will rise to the challenge versus taking some sort of lousy enterprise product and trying to give it a better user experience. And it was really hard, but it worked. Because of that, I got to form a really good relationship with the person who's now our CEO, Arvind Krishna, but back then he was head of cloud and research, because he was leading this effort for IBM to generally up-level our development capability. And there was a tool subwork stream. And since I was doing this project with GitHub and Slack, I got deputized. So I got to work really closely with Arvind for about 2 years, which was a really fun experience, learned a lot. And then in 2018, Arvind led this acquisition of Red Hat for $34 billion and set us down a new strategy, which is our current strategy, called hybrid cloud and AI. And the hybrid cloud part, we can get into that if you want, but it's basically saying that every company ends up in a hybrid cloud situation, whether they want to or not.
Yeah.
And
That
so
sounds fair.
rather than saying step one, just move everything to our cloud or somebody's cloud, we say, we're going to meet you where you're at, and we're going to try to take on that complexity for you so you can focus on your business services. But the AI part of it is different. The AI part of it is saying, just like the web in the 1990s, AI is this increasingly ubiquitous technology that people want to put into existing applications and new applications to make them better. Like 15 years ago, it just wasn't feasible for reasons we can get into. But about maybe 6-7 years ago, it started to be feasible. Everybody wants to infuse AI in their applications, either because they've got a really compelling use case or they just feel pressure that everybody else is doing it, I should be doing it too.
Of
And
course,
so
yeah.
Arvind's challenge was, you just got everybody to adopt GitHub and Slack, get them to adopt AI too. And it's like, but I don't have a background with AI. Those guys said, well, don't worry. We've got plenty of people who really understand AI. Like, there's many people with PhDs at IBM research in AI. But what we think the hard bit is going to be is actually, for lack of a better term, the cultural transformation that's required for a population who doesn't understand the technology to understand that technology and learn how to apply it at the speed that the market demands. And so I've been doing that for the past 3 years now.
Yeah, and it's been fascinating to watch the twists and turns, even in your own thinking, because you describe yourself as a traditional engineer moving into this space of hanging out with PhDs who've been thinking about AI for God knows how many years. And I still remember when we were talking about asking this question of what needed to be unlearned about AI, and you introducing me to some of the people in IBM. I was just blown away by, first of all, their clarity of how they could talk about the topic. But I just got smarter just listening to them. And so many of the notions that I had, what AI offered, could do, would do, what was good like, were sort of blown away fairly quickly, to be honest. What about you as going into that journey, right? What were some of the things you have to unlearn that you maybe believe from your traditional engineering mindset to understanding what are some of the unique characteristics of AI are different? What were some of those assumptions that you had that you actually had to either update, remove, or adapt? What are some that come to mind?
Yeah, probably the biggest one is simply that it's just such a different paradigm than traditional programming. So traditional programming, it's basically about defining rules, like if this, then that, while this, do that, for I equals 0, I is less than 10, do that. And so you very methodically describe a set of rules and you want your program to be deterministic. Like, I know exactly what it's going to do. I'm going to predict the failure conditions. I'm going to catch those exceptions. And so it's just very deterministic. And I think this is one reason why a lot of kind of introverted people get into programming, because the program does exactly what you tell it to do. And it's very deterministic. It's not like the messy world of people and culture. And so with AI, it's really about, well, let me talk about machine learning in particular. It's really about providing examples of what success looks like and what failure looks like, and then training the algorithms train on those examples until it can repeat the procedure with a new piece of data. The simple example is classification of dog and cat pictures. So you have 1,000 pictures of cats and you label them as cats. Then you have 1,000 pictures of dogs and you label them dogs. You train a machine learning algorithm on it. And then the next time you showed a picture of a cat or a dog, you hope it gets the right answer. That's a very simple example. And of course, there are much more complex examples. But I think one of the really interesting things is it's probabilistic rather than deterministic. So it's really interesting we have a product at IBM called Watson Assistant, which is basically a toolkit for creating chatbots, often for customer care scenarios, like, calling to reschedule an airline ticket or something. And when you're working to train the chatbot, you basically give it examples of utterances you would expect a person to say for particular scenarios. And then the first trick is recognizing those utterances. Like, is Barry asking about the hours of the store, or is he asking if there is beer in stock? Those are two reasonable queries that a convenience store might get, but they are very different subjects. And so when you ask a question, you want to be able to ask different variations of that question, but still have it route to the correct intent. And so an interesting thing when you're kind of building the training in Watson Assistant, you kind of give it test utterances and see if it responds correctly. But within the tooling, it'll actually show its confidence level. So it's 75% confident you're asking about hours. It's 99% confident you're asking about hours. And so then it gets into this interesting question of, at what threshold do we take action versus below that threshold, we might ask you to clarify what you're trying to do. So the way I kind of got my head around it was, I've got 3 kids, and really think about, how do you teach your kids? Like, when you teach your child to speak, it's not like you take them to the library and sit them down and start talking about grammar, because they don't even understand what you're saying. What you do is you start with very simple things like bathroom, hungry, and then over time, they start to both understand you, but also be able to make their own utterances until, yada, 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 they're able to have conversations like this one. So it's really that sort of examples, training, trial, error, feedback. That is just a completely different paradigm than programming a set of rules.
It's fascinating. And I love that separation of probabilistic versus deterministic. One of the things that really stood out to me when we were talking to one of your colleagues, he gave almost this example of Netflix when you're searching for shows. If they get a really good algorithm, they'll be 60% confident that 3 of the 5 shows they show you on your search results are like really optimized for you personally. And if they're so good with the first 60%, you don't even notice, because you, as a user, you look at the first 2 shows and go, yeah, that's what I wanted to watch. And a lot of it was actually handling the error, the 40% that actually was so off base, because you're always going to have error. And if you can handle that scenario gracefully, you have the magic of what the machine can predict and have a guess of what you might want. But if you didn't want those and you choose the other options, like, how bad are the alternatives and how gracefully do you handle them? That was such a real interesting aha for me too, as well, to hear people talk about that. It is a probabilistic approach. If you get to this confidence or accuracy level of that's good enough that it draws in the attention of users to go, oh yeah, that's what I was thinking of. Their attention is drawn to the correctness that you had rather than the error that was on the other side. That really got me thinking about like how many other things we think about when we're building these systems. And like Watson as well is such an interesting product. It's had such a varied and checkered career, right? From the early days of going to solve the chess problem, right through to being on Jeopardy, right through to where you're trying to take it today. So tell us a little bit about some of that journey, both your own experience of what you believed Watson to be as you started to join that team. And now when you're trying to like plot into the future, 5-10 years, what are some of the things you're starting to think about that maybe the company has to even unlearn from the history of Watson maybe only 2 or 3 years ago?
Yeah. Before going to Watson, though, I just want to say one thing about your point about errors. So I've studied resilience engineering a lot, inspired by John Allspaw and others. And one of the basic principles of resilience engineering is that errors or incidents are an excellent source of learning. So that's why we do things like blameless postmortems, learning reviews, et cetera, and why we try to create a blameless culture, because if people are willing to talk about both things that go right but things that go wrong, then we have a chance to get better. And I think one of the most interesting kind of intuitive examples from the AI world about learning from errors is the Tesla autopilot. So probably people know what this is, but it's basically the Tesla kind of semi-self-driving system that'll keep you going at constant speed, keep you a constant distance behind the car in front of you, and keep you between the lines. So they have a principle that anytime a driver intervenes, it's actually considered an error, and they try to learn from that. Like, why did the driver feel that they had to intervene so that they can make the driving system better and better? And so the people I know who are the best at what they do are the ones who don't kind of try to avoid all errors. They're the ones who are aggressive and try things, and then understand that they will make mistakes, that they will sometimes screw up, but then use that as a source of learning to get better. So I just see a real big parallel between people and the AI approach to software, for that errors are the greatest source of learning.
Right on. Great underline for folks. For me, then, this is what's really interesting about the journey that IBM has been on their own sort of AI journey, right? From those early moments of, I remember as a kid hearing about, it almost feels like a comic book. A computer could beat a human at something, and we're going to build a machine that can beat humans at games that we created. It just feels like the stuff of legends when I started off. And IBM Watson is the first sort of thing that came into my head when I even think about that. And yet, as you said, this promise of what AI was 15 years ago versus what it's become in the last 5 years just feels like an exponentially different world. Sure, maybe we've new technologies, we've access to better data sets, more computing power, it's cheaper, right? We can look at greater masses of information, etc. But for you, like, as someone who's been in IBM for a number of years and probably saw that project start in the company and now are suddenly leading it, what are some of the things you think the companies had to unlearn along the way about artificial intelligence, or even the way to leverage it correctly?
Yeah, I think it's helpful to kind of look at the history of AI and IBM's role in that history. There was this really famous conference at Dartmouth University in 1956 with some of the kind of the legends of the industry, like Claude Shannon of information theory, Marvin Minsky. And that's basically where they established AI as a field of study. They adopted the term artificial intelligence. There were competing terms like cybernetics from Norbert Weinberg. And IBM actually helped schedule that conference and helped kind of participate and broker the conference. So we were literally there before the beginning, and then had some real breakthroughs throughout the 60s and 70s with kind of things that are now fundamental parts of AI, neural networks, the concept of machine learning, natural language processing, speech processing. But basically, until about 2011, which is when Watson Jeopardy happened, and also that's when Siri was released, like all this stuff happened at once. Until we got to that point, AI was always considered more of a field of research study, not fit for real enterprise use cases. And there'd been attempts. There's this concept of the AI winter where like there'd been a bunch of excitement about AI and then a bunch of failed companies, a bunch of failed deployments, and then people kind of gave up on it for 5 to 10 years, and then it came back. And so when I went to college, I went to Penn State from 1996 to 2000. You weren't even offered AI as an option. Like I took computer science and you weren't even offered AI as an option because
Right.
Why would you?
Yeah, absolutely.
It's not something you're going to use. Like you may as well learn about, using a slide rule or something. You're just not going to use it. So the only people that did it were the ones who were doing research in it and were going to go into research about it. So then around 2011, a number of things like you were saying, the explosion of data from mobile devices, kind of decreasing costs of compute storage, networking with cloud computing, and advancements in neural networks like deep learning. All of a sudden, we had these things like Watson Jeopardy and Siri that made people realize, wait, it may be ready now. And then companies who were aggressive, like Netflix, just showed much better results. Google famously went just kind of all in on AI and redid their search engine with it. And all of a sudden, people were like, not only is it possible, but if we don't aggressively figure out how to do this ourselves, we're going to get left behind. by our traditional competitor who figures it out faster, by some startup who's AI first. And so there was just this incredible pressure in the industry to get on board. So with IBM, we had the Watson Jeopardy event, which people probably know it, but if you don't know it, basically a system which was called Watson basically beat the two best Jeopardy champions of all time pretty convincingly in a highly publicized event. And all these things, this confluence of events made people come to IBM and say, give us the Watson now, give us the AI now.
Plug it in. Plug it in. We want to win Jeopardy, finally.
Right. But if you look at the Watson system that won Jeopardy, it's like the size of a room, like it's a room-sized computer that was custom built to do two things: understand questions and very quickly look up answers, which are really useful functions, but a pretty narrow set of utility. So it was really good at winning Jeopardy, but not so good at other things because it wasn't built to do other things. And that's sort of one of the things that people should understand at AI. Most current AI systems are very narrow. They do one or two things really, really well, but they can't do anything else because that's just not how they work. And so it's not like we had an AI platform sitting around. It was like a custom system. And so when there was the interest in IBM and other companies helping enterprises embrace AI, it was, okay, let's grab our speech technology from research. Let's grab our vision technology from research. Let's grab this thing from open source. And so it was many different things, but not a coherent platform. And so some of them were very successful. Some of them weren't successful. But anyway, I call that the post-Jeopardy gold rush period. Not just for us, for the whole industry. We acquired companies.
See that. Right. Well, that's what happens with everything.
Started divisions, started new products that were AI first. And so that was kind of between 2011 and then 2019. And then 2019, like I said, that's the demarcation I use is when we acquired Red Hat. Then we embarked on this hybrid cloud and AI strategy. And the idea was, let's methodically infuse AI in not just a set of products, but in all products. And let's help our customers do the same thing.
Yeah.
And so that's what I've been doing for the last 3 years.
Yeah, no, it is fascinating. It's so great, though, to hear you talk about that narrative. It almost feels like the adoption curve of so many technologies, these hype cycles that lead to like winters of things. And it's sort of like the industry figuring itself out and shaking out actually how to use these technologies as they come into play, right? I feel like we're sort of the current craze of whether you're an NFT or blockchain junkie. It just seems to be a similar type of experience where suddenly everybody's trying to like print or mint an NFT because that's the thing to do, right? But is it like really understood about the characteristics of the technology where it's really applicable and instead of just bolting it onto everything, that it needs to be core of the right products at the right time? It's just fascinating to know that we go through these cycles regardless. And some of the lessons you've sort of learned along the way, right? I think that's half as you say, this sort of postmortem culture is, can you talk about the mistakes? Because if you can't, you're not going to be able to improve the systems and get better. I think it's a really strong philosophy about building any great products or figuring out the high utility and applicability of new technologies as they arrive. So tell us then more like about the new role, right? You're sort of, as you say, you've been in it for not super long, a year or two, and really starting to think about the direction forward for sort of 5 years out for AI, and to have it, as you say, almost infused into all aspects of IBM's culture. So what have been some of the challenges for you personally to sort of get into that mode of actually trying to plot what the future looks like that's already going on an exponential curve? And we're not so good as humans at plotting exponential curves. So what have you got for us?
It's easier to start from kind of the end point and then work backwards rather than to talk about sort of the beginning, because it was kind of very confusing at the beginning and like all this stuff kind of cohered eventually. But it's hard to say like when a particular kind of building block snapped into place. So basically what we're doing is we're creating kind of a product family of a set of foundational AI components that can be easily embedded in products. simple examples. So natural language processing.
Yeah.
You have a software product that maybe today the only way to query information is through a GUI or maybe through some sort of like structured query language. But you say, why can't it just work like Google? Why can't I just ask it questions in English or Spanish or whatever language it is, natural language questions, and have it figure out what I'm actually asking for and come back with a good response? So in theory, like any product could have that because every product usually has a search or query function. And so the trick is, how do you make that easy to adopt? Actually, there's kind of two big problems. So number one, how do you make it easy to adopt by a software team who may know nothing about natural language processing? And the answer to that one is you really have to figure out the intersection of software development and AI. So it sounds simpler than it is, but basically, how do you give AI componentry a really great developer experience? And at the end of the day, it looks just like any other software. If you do it right, it looks like any other software component. One of our principles is that somebody should be able to install Watson NLP just like they might install a logging library. Pip install Watson NLP, yada, yada, yada. Now you've got NLP, and it's got a great programming interface. It's got great documentation, and it encapsulates all of those advanced AI algorithms. So that's kind of one of the learnings. I keep seeing this pattern repeat. So dev and ops, design and engineering, developers and AI people.
Where you've done it a few times. Yeah, it's fascinating.
To do something really great in AI, you basically have to have amazing AI algorithms, which can only be created by people who are very deep in machine learning. They understand the whole life cycle of machine learning, and they can create those algorithms. But then you also need to be able to make them available via very understandable developer APIs, and then finally be able to run it at internet scale. Those are disjoint skill sets. And so one of the mistakes people make is they say, we want to do AI, and they invest millions of dollars in hiring some PhDs from Stanford who have machine learning degrees. And then they wonder why it doesn't work in the software products. And the answer is because you need both the machine learning people to create the algorithms, but then you need the software developers to create the APIs and kind of internet scale architectures, but they need to work together. And the two don't know each other, just like in the battle days, the developers and system administrators didn't know each other, or the designers and engineers didn't know each other. That's one of the real tricks, that developer experience for AI.
It's fascinating, though, just to hear you talk about that, though, Bill, that you keep coming across these patterns of creating cross-functional and teams to make these things work well for both sides of the equation, whether it's dev and ops or engineering and design. Or it's fascinating how often we forget. We have to keep learning some of these lessons again and again and again. Is that like not one discipline is necessarily going to solve it. It's always an and just reminding ourselves of that sometimes I think is really important because the easy thing, as you say, is to go out and go find these people who are deep on one specific skill and they'll have all the answers. Well, sure, they'll have lots of expertise, but are they going to create a usable, functional product or experience for others to use it? And that's a really, like you said, you went and spent 2 years in the design school where most of your engineering colleagues said, why are you going here? You're going to miss out on 2 years of learning more about engineering rather than thinking about building great product experiences. So when you do great engineering, you just don't launch these things with a thud. They've got the user needs. You almost understand user needs better than users understand them themselves, as you said earlier. It's just fascinating to me, though, that we seem to have to relearn these lessons again and again and again at some cost. I don't know why we do that. I'm curious what your thoughts are there.
Yeah. Before talking about why we do it, the analogy I always use is a soccer team. Say you wanted to start a soccer club and try to be competitive in the European League. You wouldn't go out and hire 11 goalies. You wouldn't hire the best 11 goalies in the world. I mean, you'd have the best 11 goalies in the world, but you'd win 0 games. And so the term we came up for it was the whole team approach. And actually, the Whitewater project that delivered the software tools, the metaphor was a water rafting team where in the picture, we said this person's dev, this person's ops, this person's design, this person's HR, this person's finance. And in the whitewater rafting team, it's not like this person could succeed and this person can fail. You either navigate the dynamic, treacherous conditions together and succeed together, or you all tip over, or you all go over the waterfall, or you all crash. So basically, I believe that to do anything good or anything excellent, you need to get different disciplines actually collaborating together, not just coordinating, but actually collaborating. And that requires them to have a bit of a T-shaped skill set where they are deep in something like engineering, but they know just enough about design to understand how the designers add value and when they should proactively reach out to them rather than just showing up to a couple status meetings every week and coordinating.
Yeah, I know, right on. Awesome. So what was your other point?
So I said the two really hard things that I found with creating basically foundational AI components. The first one is that fusion, that synthesis of really excellent machine learning algorithm creation and excellent software development for both creating the APIs, but also creating the internet scale architectures. So that's hard problem number one. Hard problem number two is how do you create an innovation pipeline? So basically, we've got this incredible research capability. That's one of the most famous research capabilities in human history. IBM research goes back many decades and has had fundamental advances in computing. But it's actually really hard to commercialize a very innovative thing. And there's, examples of this from history. Probably the most famous example is Xerox PARC inventing the graphical user interface and Apple commercializing it.
Absolutely.
So basically, one of the real hard problems to crack is how do you repeatably get innovations into the market much faster and at much greater scale than you ever have before? And probably unsurprisingly, the answer is two parts. One is good architecture, and then the other is good collaboration between research and developers. Some of this stuff seems so obvious in hindsight, but I'll never forget talking to researchers about how they could more effectively deliver into the Watson code base and basically using the term pull request, which is sort of the GitHub mechanism for contributing code such that it could be reviewed. Probably used the term pull request about 30 times in a 30-minute meeting. And at the end, I was, any last things? And one of the researchers said, "What's a pull request?" And all the other researchers were like, "Yeah, we had the same question." And so that sort of just assumption, coming from a development culture where pull request is, the air that we breathe, to a research culture where what they really have to do is they spend more time at their whiteboard than they spend at their computer, as they should. And so for them, the computer is sort of like the last mile to express the thing that they figured out. So the good architecture part basically is modularity and extensibility. So if you have a highly modular architecture and basically a way to very easily snap in new things in a consistent way, then two things happen. Number one, the researchers can actually develop within that architecture because it's just easier, which means that a lot of times what happens is if the researchers are just kind of doing their thing on their laptop, when it comes to the product team, the shape of it is so different than what the product expects that the product team either almost has to rewrite it or literally has to rewrite it, which really increases latency in the system. So if you have a really good modular architecture, they can actually program in the architecture of the system just because it's more efficient to do the work. And then when they give it to you, all you have to do is probably fill in some exception cases, do some better logging, and you're off to the races. And then extensibility is a really interesting one. So extensibility is, there's this principle from computer science called the open-close principle, which is closed for modification, open for extension. And if you think about something like the iPhone, the kernel of that you can't change. You literally can't change it because there's no programming interface to get it. Only Apple can change it during the software update, but you can install applications, and that's the way you extend the capability of your iPhone. So with the research development collaboration, it's kind of a funny thing to say, but quality is not the most important concern for the work that the researchers do. Innovation is. And so if you try to force a researcher to create bulletproof code that can run at internet scale perfectly securely, the researchers are just going to quit because that's not their job. So if you have a really good extensibility system, then you can basically allow them to run their new thing that might not be high quality, may not be secure, as an extension to the system in the test environment, and therefore just move really quickly than if you had to like get all the code into the kernel of the system and really assiduously review it. And also then it allows them to do kind of first of a kind experiments with customers where a customer may be running the test code and they put it in some sort of other kind of sandbox because the point is to see how it can help their business. It's not a production system yet. So the good collaboration, modularity, and extensibility can create a really great innovation pipeline. And if you put the two things together, the adoption and the contribution, then you all of a sudden can have a single research innovation go into like 20 or 30 products instead of just one.
Bill, it's just really fascinating to hear you talk about this. One of the things I'm grappling with at the moment in our venture studio is we have this notion of trying to do 100 companies in 5 years, just like high velocity company creation at a sort of scale and speed that I've personally never done before. I don't know if anyone's done before. And it's really interesting in the analogy where I'm thinking of is we have ideators, entrepreneurs, people who are dreaming up these ideas of future scenarios for businesses that spend most of their time on whiteboards or discussing ideas or thinking of these sort of interesting scenarios. And if you start to tell those or constrain those people too soon about, well, how are we going to build that? And what is actually the feature that goes here? And what's the experience for that that you're describing? It stifles them. It frustrates them as well, where you're trying to capture the essence of these like lightning in a bottle moments and then start to transition them into a process to productionize it or to make it, as your analogy, a robust, scalable system that can be delivered to millions of people, right? And in the company creation process, it's standing up businesses that actually make sense and finding very targeted markets to test with and build. And it's fascinating building those systems and thinking about the collaboration, as you describe, that has to happen with these highly, highly exploratory sides of ideation and research, and also the productionization of these things, whether it's engineering teams or, yet again, it is ultimately engineering and product development teams in our studio. But the meta ways for teams to be able to collaborate, like structures, a good architecture for what you expect from one side to help the other keep building. It's really fascinating. You just keep reminding me of that. I was hearing you talk about it as well.
One thing I forgot to talk about is composability. So kind of the flip side of modularity is composability. One thing that's an important meta point is that Watson Jeopardy was 2011, so 11 years ago. That means that we have 11 years of experience of creating internet scale AI infused applications. One of the things that we've just kind of internalized is that composability ends up being important to all these systems. When you ask a chatbot a question, you may naively think that an AI model answers the question. In fact, what happens is about 50 AI models answer the question. And so they have to be composed together in both a way that's productive at development time, but also at runtime to give that answer back. So a lot of what we do is spend time on thinking about how can we make it so that the output of one module can become the input of another module without the algorithm creator even having to think about it. It ends up looking a lot like Unix. Like, in Unix, you can write a command and then pipe it to the next command and pipe it to the next command. And all of a sudden you created a little program with just like a very simple expression. The composability of the AI algorithms is a major focus area. And when you get it right, it dramatically increases the innovation throughput.
Looking forward then, what are you most excited about? Where the industry is going, the role that you're a part of? What's sort of lighting you up or helping you sort of jump out of bed in the morning?
I think it's really just the AI being more of a commonplace thing in part of the application development lifecycle. The analogy I use is the web. So the web is kind of easier to demarcate than AI in terms of when it began, because it began with Tim Berners-Lee creating the three fundamental technologies, HTML, HTTP, URL in 1993. But it wasn't until 2004 that Ruby on Rails was created. And so I look at that 13-year period as sort of like a period of exploration where people were trying to figure out, how do I create good web applications? And then you could argue that there were things that came before Ruby on Rails, but you can definitely say that Ruby on Rails did an amazing job of encapsulating best practices that had been learned in those 13 years in such a way that you could really just focus on your application development.
Okay, totally.
So right now with AI, we're still in that sort of 1993 to 2004 period where there's lots of construction required. People don't know what the patterns are. So there's lots of things go wrong, things go much slower than they should. And so the thing that I would be really happy to see is if a few years from now, people include AI in their applications, just like they include web in their applications. And it's not a big deal. It's kind of mundane. And I would like Watson to play a role in making that true.
Well, I'll tell you what, Bill, if there's anyone who's going to play a part in making it happen, I think it's going to be you and the team. So thanks very much for coming on the show and sharing some of these insights and experience with us. And it's always fascinating to have these conversations with you. I get smarter and learn a bunch. So thank you very much.
Oh, my pleasure.
Hey, everyone. I hope you enjoyed that show, but I'm even more delighted to share the exciting news. I've recently co-founded a new venture studio named Nobody Studios. Now, Venture Studio is a vehicle for the rapid creation of new companies, from ideation to acceleration and growth. And our purpose at Nobody Studios will be to de-risk pre-seed stage business ideas. We'll do this by minimizing the time, speed, and capital involved in validating truly repeatable and scalable business models before any significant venture investment. We've an audacious goal to start 100 compelling companies over the next 5 years, and who knows how many beyond that. So if you're interested in radically changing the way work is done, how products are created, companies built and funded, even democratizing the wealth creation and how returns are distributed, this could be the business for you. We're looking for talent, capital, and influence. If you wish to contribute any or all of these, just get in touch. You can follow us on nobodystudios.com, on our LinkedIn page, all the social media accounts, or simply my newsletters and what I'm sharing. We'll be launching a truly innovative crowdfunding campaign, and I'd be honored if you'd be willing to join us on this journey and become a